Hello, I'm Mrs. Vaishali Samant. I invite you all to Saraswati Tutorials. If you like my videos, please share and subscribe those videos. And here I am discussing last 15 years problems from C.E.T exam. This will be useful for other board C.E.T exams also. If you like my videos, please share, subscribe, like it and press bell icon also. Here I will explain you some theorems from matrices which already you have done in 12th exam, for 12th exam. If A is a square matrix of order n, then determinant of adjoint of A is determinant of A raised to n minus 1. If it is of order n, then determinant of this is this. This is very useful. Many questions are asked based on this. Adjoint of A is determinant of A raised to n minus 1 into A. See, this is a matrix, no? So this A is not included here. This is a matrix, this is a number. This is very important theorem. If it is of order n and from determinant if you take k common, it will come as k raised to n out. From matrix if you take k common, only once it will come. But from determinant if we take common, it will be common from each row separately. So it will be k raised to n into, this is very important result. Adjoint of ka is equals to k raised to n minus 1 into adjoint of a. A inverse is 1 upon determinant of a into adjoint of a, provided determinant of a is not equals to 0. Both if I'll multiply by a from this side, a inverse is a adjoint of a divided by determinant of a into I. So this is also important property. A into adjoint of a is this into this. I we have to write, usually when we multiply I, it becomes acts like 1. But here what happens, this is a matrix. And if I will not write I, it will become a number. So it is wrong. So we have to write I here. This is important here because this is a matrix. If A is singular matrix, then determinant of A is 0. And in that case, A adjoint of A is 0 matrix. This is 0. So this will be a 0 matrix because I is there. Another important theorem is, if this is diagonal matrix, its inverse, we write it as 1 upon A, 1 upon B, 1 upon C inverse. Or sometimes this is written as, this matrix is, okay, this is ABC, its inverse is 1 upon A, 1 upon B, 1 upon C. A is this, is square is I. Even for this also A square is I. And this is very important property. B inverse, A inverse, inverse. If we will reverse it, A inverse inverse into B inverse inverse, that will be AB. When I am explaining, you may think that why she is explaining like this. This is very easy. No. But see, if A and B two matrices are given and if you have to find out this, what you will do? You will find out B inverse, A inverse, then product and then inverse. It is not like that. Its value is AB. So you find out AB, that will be the value of this. So that will be the shortcut method. This problem is there in many papers. If A and B are square matrices and B is equals to minus A inverse BA, then AB square 4 values will be given. You will have to select one. So which is answer is given here. I have given you answer, but 4 answers will be there. One will be A square plus 2AB plus B square also. But that is true in real numbers when we square. Here it is not there. See here. B is minus A inverse B inverse. This is given. What I will do, I will multiply from this side A. Which side you are multiplying, it is important. Once this side and once this side you cannot do, because in matrices AB is not equals to BA. So this side I am multiplying. So AB is equals to, you multiply here A inverse will become I and it will become BA. And AB is equals to minus BA. So AB plus BA will become 0 because of this. And if I will expand this, don't expand it as A square plus 2AB plus B square. Because here AB is not equals to BA. So we have to write A plus B and AB separate, BA separate. In real numbers, these two are same. That's why we write twice. But in matrices, it is not the case. But here it is given, this is 0. So this will be 0. So this is the answer. So this, if you read 2-3 times, you will remember this answer. And this is first round problem. Means as soon as you will take paper and if you read, you know the answer, you can suddenly tick mark it. This is very important. Another one. This is also from papers. A is non-singular matrix and a square minus a plus 2i is equals to 0. Then A inverse is this. What I will do for this, A inverse I will multiply from both sides. If I will multiply here, it will become A inverse, A square will become A. This will become identity and this will become A inverse. This you shift other side. So A inverse will be half into bracket I minus A. This problem is also there in many papers. 4 options are there. Now this is very important result we have done in 12th standard. If Ax is cos x sin x 0 minus sin x cos x 0 0 0 1, especially this matrix only, then Ax into Ay is A of x plus y. Remember here cos, here minus sin, remaining 0 0 1. This matrix only. And this we have proved in 12th standard. If I'll put y is equals to minus x, then it will become Ax into A of minus x is equals to A0. This question is asked many times, but how the question is asked, I will explain you. This and this, if we will add by using this, it will become A0. A0 means what? Put x is equals to 0. You will get identity. If you will put 0 here, sin 0 is 0, cos 0 is 1, so you will get identity. So you got this identity. Similarly, this into this also identity. So inverse of this is minus. Inverse of this is minus. So this example, if fx is this, then fx inverse is f of minus x. This is asked many times in the examination. So this is equal to minus of this. For 2 by 2 matrix, you know inverse, it is 1 upon determinant of A. This you reverse and attach negative sign to this, where A is this. So this we can find out inverse like this. So this orally we can find out, no need to write adjoint and all. Some important examples from the papers I will take. These are from C.E.T also. If D is the determinant of A of order n, determinant is of order n and D is the determinant of A. Sorry, matrix A is of order n, determinant of A is D. Then what is adjoint determinant of adjoint? Which answer is correct? By formula, you know this is determinant of A raised to n minus 1. It will be d raised to n minus 1. If it is order 3, it will become 2. This problem. This is also taken from paper. A into adjoint of A is this. What is the determinant of adjoint of A? We know A into adjoint of A is determinant of A into I. This property I told you. So if I take 4 common here, this is a matrix. So from all we have to take common, so only it will come once. So 4i. So determinant of A is 4. Here we got, this is very important step, you should remember. Here determinant of A is 4. And determinant of adjoint is determinant of A raised to n minus 1. Here n is 3. And determinant of A square, determinant of A is 4. 4 square, 16 is the answer for this problem. Be careful, this is important. Read it 2-3 times, you will understand. Another thing, we know determinant of A and determinant of A transpose is same, because in a determinant, if we interchange rows and columns, its value is same. So in a matrix, if I take transpose, its determinant will be same. And you know adjoint, how we are finding? We are finding cofactor of A and its transpose. And therefore determinant of adjoint A and determinant of cofactor of A transpose is same. But in determinant of transpose and that determinant is same, so it will be same. So remember, determinant of adjoint of A is determinant of cofactor of A. We know formula for determinant of adjoint of A. We don't know formula, but this is equal to this, we can make use of it. See here, if A is 3 by 3 matrix and determinant of A is 11, it is given. Determinant of cofactor of A is what? Determinant of cofactor of A, just now I told you here, it is determinant of adjoint of A. And determinant of adjoint of A, by this formula, it will be determinant of A raised to 3 minus 1. Determinant of A square. Determinant of A is 11, so answer is 121. If A is 3-rowed square matrix, means 3 by 3. 3-rowed square matrix. And determinant of A is 0, then adjoint of adjoint is which one? There is a formula, adjoint of A, I give you formula, is determinant of a raised to n minus 2 into a. N is 3 here, so you will get here 3a. When I will take determinant, because it is of order 3 by 3, from determinant when I will take 3 common, it will come 3 raised to 3 outside. This is important step. From matrix, if you will take common, it will come only once. From determinant, if you will take common, it will be 3 raised to 3 into determinant of A. So 27 into determinant of A is 3. So answer is 81 from this. So be careful here how we are doing. This also important thing. This is also important thing. Now this is very important result. See here, if A is this, if you will square it, you will get 0. So very important property we got in matrices, A square is 0 but A is not 0. Matrix A square is 0 but A is not 0. Usually in real number what happens, if x square is equals to 0, we write x equals to 0. It is not the case. Now this problem is there in many papers, even in C.E.T, C.E.T, C.O.M.E.D, everywhere this question is asked. A square minus 2a plus I is equals to 0, then what is the value of a cube? It is asked. See how I am finding. A square, I know A square is, I will shift this other side, 2a minus I. So a cube will be, multiply this by A, this by A. It will become 2a square minus A. A square I will substitute here. So answer is 3a minus 2i. This answer is there. But if you make mistake here, see, this is a square. A square minus 2i plus ai is a perfect square. So if perfect square is equal to 0, then this equals to 0. By mistake, if you write, you will get a is equals to I. So if a is I, a cube also I, you will get that answer. But this is wrong answer because this step is wrong. Because even though a square is 0, a need not be 0. So be careful. Wrong answers are also given here. See, this is a cube is equals to I, it is given. It is wrong answer. This is correct answer. Another important property we have proved in 12th standard, x square minus a square is x minus a, x plus a. X cube minus a cube is this. X raised to 4 minus a raised to 4 is x minus a, its degree less than 1. Degree of x is decreasing, degree of a is increasing. So here there are 4 terms. It is like this. So general formula we have done it in limits. X raised to n minus a raised to n is x minus a into, if it is n, here it is n minus 1, n minus 2, n minus 3, and a, here a raised to 0, a raised to 1, a square, a raised to n minus 1. It is like this. Now this problem is usually asked in the examination. If A is a square matrix such that a raised to k is 0, then what is the value of I plus this? It is 4 answers are given, you will have to select one from that. You know I minus a raised to k is equals to I raised to k minus I raised to k minus a raised to k. I raised to k is I only. And by this formula, it will be I minus a, a square, a raised to k minus 1. So this will, and this is 0. This is 0. A raised to k is 0, it is given. So this into this will be I. So value of this will be I into inverse of this. Don't take denominator, this number, the 1 upon you don't take because this is a matrix, you cannot take it. Because this is 0, here you got this. I you can remove, so this is your answer. So value of this is this inverse. This problem is asked many times. Similarly, if a raised to 5 is 0, what is the value of this? Same method, I minus a raised to 5 is I raised to 5 minus a raised to 5. So by using this property, it will be I minus a into this. This is 0, so this will be I. And therefore value of this will be inverse of this because this into this you are getting I here. Similarly, this into this also you can write here this into this. So that will be I, and therefore this is inverse of this. Today I will stop here and next time I will continue this topic.